Mike Rothman is a 25-year security veteran specializing in protecting networks and endpoints, security management, compliance, and helping clients navigate a secure evolution to the cloud. He teaches cloud security at Black Hat and other major industry conferences. In addition to his role at DevSecOps, Mike is the analyst and president of, how do you pronounce that? Securosis.
Yeah. Good morning, Chattanooga. How you guys doing? I'm impressed. I'm impressed by the crowd. I am. We'll talk about a little bit of security. First, I was introduced a little bit. Let me talk a little bit about me. So it says 25-year technology professional, lots of road rash. I've screwed everything up probably twice. Learned a little bit, and a lot of what I do now is to try to communicate some of those lessons that I've learned over the years, try to help you folks maybe not make so many mistakes. But of course, this is technology, so things are changing almost every day. Okay, multiple times a day, right? So staying on top of things is a full-time job. I started out as a mainframe programmer. I don't see a lot of gray hair in the audience. Everybody remember mainframes? Yeah. Oh, that's a decent amount. All right, my people. Tetris? Yeah. A couple? Less so? Pong? How about Pong? All right, a couple Pongs out there. So I try to date myself right up front, like carbon dating, just chop a piece out of my leg and you see how many, rings. No? All right, tough crowd in Chattanooga this morning. That's okay. So started off as a mainframe programmer, got into local area networks and other kind of networking things, ended up getting pulled into security, which was, God, close to 25 years ago, maybe over 25 years ago. I've been trying to get out ever since, but like the mob, security just keeps pulling you back in. So I've been unsuccessful in being able to escape security in any way, shape, or form. So just let me get a sense of the crowd. How many folks are responsible for security? Only a handful. How many folks have heard of security? Okay, almost everybody. Good. That's a good place to start. How many folks know their security person? Almost half. Okay. So there's probably somebody, for those of you who don't know your security person, there's probably somebody who is responsible for this. You must be very good at your job if you haven't heard from them. Because normally when you screw something up, or they could be bad at theirs. That's true. That's a great point. In terms of day job, I actually have 2 day jobs, which makes things pretty confusing for me. Over on the right is my research business called Securosis. We've been doing this for, 14 years now, I guess. I've been associated with them for 11. We basically do a lot of publishing, and honestly just got lucky. We started doing cloud stuff back in almost 10 years ago now, partnered up with the Cloud Security Alliance, have a huge hand in the development of the Cloud Security Alliance guidance. And as was said, I've been teaching cloud security at Black Hat, which is a big security conference out in Vegas in the summer. And by the way, if there's somebody you know that you don't like, tell them to go to Black Hat, because why else would you go to Vegas in the summer, right? It's literally on the surface of the sun in the middle of the summer. But a whole bunch of security people and hackers show up, so I've been teaching cloud security there for a long time. While I was learning about all this cloud security stuff, we stumbled upon an idea for how to do a bit of cloud security automation. So we spun that out of the research business about 2.5 years ago. That's called DisruptOps. It is a cloud security posture management product, but we also do automated remediation, enforce guardrails, best practices, etc. So, again, it is kind of confusing for me on a daily basis. Am I wearing my research hat? Am I wearing my product hat? But at the end of the day, what it is about helping folks achieve a better security posture in the cloud, regardless of whether it's our tool you're using or our guidance and design patterns to make that happen. So I always start with this quote because I actually studied operations research and industrial engineering back in college about 1,000 years ago, and I just love this quote. Right, it's from W. Edwards Deming. For anybody that's done in industrial engineering, I mean, this guy is a legend, right? So it's not necessary to change. Survival is not mandatory, right? And that's kind of where we're at now. Everything about what we're doing in terms of developing technology and deploying, delivering technology is changing, and it's changing rapidly. If you're not cool with that, you're in the wrong business. right? The fact is that most of you are here today to do, at a con called DevOps Days, means you're probably okay with that, so that's a good start. Some of you may be here for the fruit platter. Anybody fruit platter? Yeah, some? Better than, so if you were a security crowd, I'd say it's better than sitting in your office and getting your teeth kicked in every day, because that is pretty much what security is like, but we'll get to that. So what is this DevSecOps thing? I need to read this to you, right? The mindset established by DevSecOps lends itself to a cooperative system whereby business operators are supplied with tools and processes that help security decision-making along with security staff that enable use and tuning for these tools. I have no fucking idea what the hell that means. Absolutely none. Right? So I tell a different story that talks about, and I'll give you a little bit more of a mindset into security folks, right? So DevOps happens, and security folks are like, where's the security? I mean, where's the security? You got to think about security. It's just this DevOps, it's happening. You got developers, you have operations people. It's like cats and dogs working together and not killing each other. It's total heresy, and there's no security there. And the thing you need to understand about security people is that a lot of them have low self-esteem, right? I mean, it's true. Right? I've been doing this for 25 years. I know these folks, right? I am these folks. Low self-esteem. Why? Because it's a job that you literally cannot win. You can't, right? So you come home at the end of the day, you go, to your significant other. They say, hey, how was your day? Oh, great, great, great. How was your day? My day was awesome. And they say, really? Your day was awesome? What happened in your day? Nothing. Nothing happened today. Because for a security person, and again, James, you were talking about incidents and all that kind of stuff for an ops person too, when nothing happens, that's a great day, right? So for security people, it's kind of like bizarro world. So you got these folks, right? DevOps starts to happen. You got this group of security people with low self-esteem. They're like, oh God, what's going to happen to me? Right? What's going to happen to me? The DevOps is happening. There's no security. So we need to get security into the DevOps. Right, and it's not Dev, it's like kind of Ukraine. It's not the Ukraine, right? It's the DevOps. So for security people, it's the DevOps. We got to get security into the DevOps. And, so the DevOps people are like, all right, what do you have in mind? They're like, well, DevOps, of course, right? Security's got to be the most important thing. Security person, go away. Not going to happen. Okay, how about DevSecOps? Right? How about that, right? Because then you can think about it, and security is kind of there. You need it. It's within DevOps. It keeps it front of mind. So there was negotiations in the back room, and that's what they decided on. So as opposed to this totally obscure word mess, definition, it really gets down to the fact that we've got two aspects of DevSecOps, right? The first, let's call DevSec. So put the parens around Dev and Sec. That's what you have to do at the front end of the process, right? What do we have to do to make sure that the code that we're developing is actually secure as we're developing it? And then you kind of switch the parens on the other side, SecOps. That's what we do once the code that's developed at the front end is actually deployed in the back end to make sure that we have strong security operations. So that is a totally made up story to try to give you a sense that security is something that we all have to start thinking about. It's all something that as infrastructure starts to move forward, as development moves forward, as all these practices totally evolve, we have to think about things differently. So, let me ask you a question, right? In 10 years, is security even a thing? And I told you, right, when I started, I've been trying to get out of the security business for like 25 years. I think I finally figured out a way to do it, right? Because in 10 years, my hope is that we don't have DevSecOps, right? We just have DevOps with security involved in it. That's what we want to get to. We don't want to think about security as a thing. We want to think about security within everything. That's the important aspect. That's what I try to preach wherever I can go and talk about these things, right? But understand that security folks, again, besides the low self-esteem, maybe a little paranoid, maybe. But remember, security folks get up every day and they try to figure out how they're going to get killed. Literally. Because you're sitting there thinking about what can be attacked, what are my developers doing to, kind of increase attack surface, what are my operations people doing, what kind of configuration changes are they making that is going to make it very easy. I think somebody made a joke before about, kind of put SQL Server up, not patched or not behind a firewall and see what happens. I can tell you what happens. It's not good, right? It's not good. So if there's kind of a category of not good, that's where it is. Right? So you have to think about these things, and security folks have to think about that. But let's kind of hit the first thing, right? Because I called the talk "Quick and Dirty DevSecOps," right? And I got to apologize a little bit, right? Because it's a little bit of a red herring. Because the reality is there is no quick and dirty DevSecOps, just like there's no quick and dirty DevOps, right? It's a cultural transformation. It's a different way to do things. It's a different way to attack specific problems. It's really a fundamental shift in how we are building the factory of making software moving forward. So this is not a quick fix. It's not something you just wake up morning and say, I think I'll do DevSecOps. That sounds like a good thing to do today, right? It's something that we work to, we iterate towards, we screw up, we iterate some more, we screw up a lot more, something changes, we screw that up, and then at some point in the future, hopefully things move a little bit faster, right? Hopefully things move a little bit better. So I was making a joke, I was doing a cloud security workshop, it was probably 3 weeks ago, making a joke about waterfall. Anybody remember waterfall? Yeah, so they're making a joke about waterfall. Oh, the old way of doing things. Anybody remember waterfall? Do you get nostalgia? Somebody raises their hand. I go, yeah. He goes, hey, we moved to Agile about 2 years ago. You know what I call it? And I said, what? They go, faster waterfall. So, yes, the cultural thing takes a little bit of time to get to, right? Kind of a lot of these evolutions are not going to be overnight things, so there is no quick and dirty, but what it is and why it's important and why I kind of try to talk to as many DevOps crowds as I can is because there is a bit of shift of philosophy to really embrace this DevSecOps thing or the sec piece of it there. And what does that look like? It looks like 3 different sections we'll talk about, and I'll go through it quickly. And by the way, I'll post the slides somewhere. I've got a whole mess of bonus content that I don't have time to get through in 30 minutes that comes from a lot of our training courses, but open source tools, and I'll give you our GitHub repository so you can take a look at some of the code stuff that we put up there as well. But we'll talk about secure architecture. We'll talk about actually protecting your pipeline, since there may be something like, your source code in there. So thinking about how we protect that, could be pretty important. And then what those secure ops processes need to look like moving forward. So let's talk architecture first, how to abuse the shared responsibilities model for fun and profit. Anybody familiar with the shared responsibilities model? Okay, a couple. So this is something that the NIST put out. It's been adopted by the Cloud Security Alliance. It's this idea of when you move to the cloud, right? And DevOps and cloud are pretty, closely aligned. When you move to the cloud, there's stuff that you have to do, and there's stuff that they do. Right, so the stuff above the line, that's what we do, right? Host server security, network identity management, management plane configuration security, data and application security. Down below the line, right below the management plane, our interface to manage the environment are things that they're responsible for, right? Physical infrastructure, virtualization and abstraction, and application and platform as a services from the Department of Redundancy Department. Right, I should probably change my slide, right? Because PAS service is kind of redundant there. Wow, tough crowd in Chattanooga. Either that or I got to get some new material. You guys, you can come up and tell me after. So the secret, right? The secret, listen here, everybody paying attention. The secret to being good at cloud security is taking the stuff that we're responsible for up at the top, above the line, and systematically making it somebody else's problem. So when we say abuse the shared responsibilities model, that's what we want to do. So how many ops folks have lost weekends updating databases, right? Or load balancers or network switches or any of that kind of stuff, because you can't do it during the day, right? I cut my teeth. Anybody remember a tool called Lotus Notes? So back like 1,000, maybe it was 10,000 years ago, and I haven't done the carbon dating, I was actually a Lotus Notes implementer, and we had to do all of our work. I was working on Wall Street, and we had to do all our work in the middle of the night, because the traders would come up and they'd need their notes to do whatever it was that they were doing, and I couldn't mess with their equipment during the day, so I had to do everything at night, right? That sucked. I was in New York City, it sucked, right? Don't do that. So lose load balancers, switches, kind of databases. If I'm using somebody else's service, guess who stays the weekend? Not you. Because you're just buying it as a service. That's the point, right? Make your problem into somebody else's problem. That's how you get good at cloud security. You think about how you can fit your infrastructure to the application as opposed to vice versa. So how many folks had this conversation in the past? So you go to the enterprise architects and you go, I need a data store. They're like, pick any data store you want. Whatever works for the application, it's cool, no problem at all. What? Any data store I want? Wow. So then you get out your CDW catalog. I'm just kidding. Nobody buys from CDW anymore. But so you get out your catalog and you're like, what data store am I going to use? And anything like they're not a sponsor, are they? I may have just totally stepped in shit there. So you go into your catalog, you're trying to figure out the data store, and they go, oh, you can pick any data store you want as long as it's Oracle. Because we have a site license to Oracle and you're using Oracle. Well, the application, site license, Oracle, use it, right? So that's kind of, we've been fitting our applications to this broken infrastructure that we've had since I started in this business a long time ago, not vice versa. So now what we can do with cloud and DevOps and a lot of these agile, not faster waterfall, real agile type stuff, is to build the infrastructure that our application needs. Right, to actually think about how we can use architecture as a design, as a security control, right? Not trying to retrofit broken security processes on top of broken architecture that by definition is open to everybody, right? So isolation, things like that, by definition, architecting it with that in mind, right? So start with architecture, leverage your account, your cloud accounts or your DevOps accounts, your virtualization accounts as these security boundaries, right? So that you can't get from one to the other. One of the easiest things for an attacker to do is just pop somebody in finance, move laterally into your data center, and good night, right? Because you don't have those defenses. Once they get into the data center, they have access to everybody and everything. But if you build your environment with these boundaries in place, yeah, it's a shame. Right? The one in the middle just got popped. Boo-hoo. Well, it's a bad day, to be clear, but it's not a horrible day. Right? Because when somebody pops the one in the middle and they can go to the one on top and the one on the bottom, that's the difference between a really bad day and a fucking horrific day. Right? That's the difference. If we can contain these things, if we can isolate these things, then we're in a much better position to move forward. And we can think about architectural and different design patterns that weren't possible in other environments. So this is a design pattern for an analytics application. So what does this look like? We got data in the corporate data center. We move it into the drop bucket, so that could be a push or pull. And then we build the stack, right? Because this magical code thing, somebody mentioned Terraform. You mentioned Terraform before. Magically Terraform, right? Sprinkle some Terraform dust on this and the infrastructure sprouts up out of nowhere, right? Because we need it then. We've got functions in there which are magical. It's just code that you load up somewhere and it just runs. I don't know how the hell that works, but I'll suspend disbelief for a little while and let that happen. So we build this application stack. It's for analytics. Math happens in the back end. Once it's done, we move it to the results bucket, and then we send it out, right? And we pull down the analytics stack in the middle of that because we don't need it anymore. So what do you attack in this environment, right? Hardly any of this stuff exists. What do you attack? It only exists when you need it to. So, of course, somebody, and this is what happens when you hang out with hackers too much, right? So I say, what do you attack? And some guy goes, you can't be that dumb, Mike. And I'm like, well, I'm pretty dumb, but what are you talking about? He goes, I attacked the corporate data center because that's the path of least resistance. Cheater. Right? I mean, what else do you say to it? Somebody who actually has the right answer, but, cheater. That's cheating. That wasn't my question. My question was, what are you attacking this stack? He goes, no, I answered what I would do if I was attacking it. So that's another thing into security philosophy. But the point here is, for this specific attack, or this specific technology stack, very, very difficult to attack. You have to be really good, and the only thing that's open is when you have opened that port to move the data, and when you open the port again to move it out. That's pretty much your attack surface. So again, these are things that you think about when you're designing, again, these newfangled stacks. Another one that we use for the first version of our architecture, elastic load balancer, go in a web server, you actually put data into a queue, which then is transferred back to the processing server, back into a database paths, because I didn't want that to be my problem. I made that into the cloud provider's problem. And once the processing is done, we communicate back to the user via a notification, right? No direct connectivity between the web servers and the processing servers. So again, what we're doing, systematically reducing our attack surface, systematically trying to make our problem into somebody else's problem, and thinking about architecture more creatively to allow us to build, by definition, a more secure stack. Then we get to immutable infrastructure. Anybody heard of immutable? Yeah, so that's this idea that we don't log into stuff anymore because all of our infrastructure is actually in code. So what's that? Stunned silence now, all right. Okay, got it. So what we have there is our infrastructure. So we make a change. So then we see the change. It moves into our continuous integration pipeline. It does a whole bunch of tests there. And then the running instances are replaced. We'll show that a little bit later. But what this does is it allows us to have very standard infrastructure without any variability. And again, security folks hate variability because that usually means somebody has screwed something up. So if we can get it to a point where you can't log into it, can't make any changes. When we want to make a change, we do it at the fundamental level and then roll that through the rest of the infrastructure. Life is a lot better for us. So what does that do? We don't update anymore, although operations people do have a little bit of a problem with this because anybody miss Patch Tuesday? Yeah. And what comes after? Anybody know what comes after Patch Tuesday? What's that? Downtime Wednesday. We have a different word for that in security parlance, but that's exactly right. We call it Exploit Wednesday. So Patch Tuesday, Exploit Wednesday, because the attackers actually reverse engineer all of the patches, and they know that you suck at operations. Well, not you guys. I'm sure you guys are great at operations. It's everybody else that sucks at operations and knows they've got a 30-day window at least to weaponize that exploit and use that to break into your stuff. If we've got immutable, well, yeah, we're still kind of vulnerable from that standpoint, but we can move things through a lot faster. Somebody remember Heartbleed? Heartbleed, big attack on the structure of the internet. You know, AWS allegedly patched their hundreds of millions of servers within a week. Maybe it's true, maybe it's not true. It's a great story, but it really points to what we can do with kind of infrastructure as code and immutable as a mechanism of doing that. So architecture, so the point here, secure architecture and DevOps is cloud security. What we can do is we can reduce our management service, we can reduce our attack surface by systematically using architectural constructs. We can embed and automate security processes within the structure of what we're doing. And basically, security folks aren't proud. We just stole a lot of the stuff that DevOps people have been doing for a long time to reduce a lot of the boundaries between these different groups. And hopefully everything works together a lot better in practice. Right? Because then I talk to a bunch of folks and they go, yeah, we do these 2-week sprints and we got all these security features that always seem to move to the bottom of the list. So if you're not actually fixing your security features as part of your sprints, well, that's a different issue, isn't it? Not a structural process. So I think somebody said, don't blame the person. That's the person, right? That's not the process. That's the person. Right? We're deciding to deprioritize security issues. So how are we going to do a secure pipeline? So again, we've got all of our code within the pipeline, and we're going to add this little box, not functional and non-functional tests anymore. We're actually going to do security tests as part of the process. We will show how that works. Here's our little pipeline. First thing we're going to do is look for the credentials that are used in the files for the build. So we want to make sure that we don't put things like API keys in our source code and then upload them to GitHub. I actually have a story about that I don't have time to tell, which I'm actually sad about because every time I can make my business partner look like an ass in front of a big crowd of people, I like to do that. But I don't have time to do that. But suffice it to say, he uploaded our API keys and Litecoin mining ensued. We're going to build it. Right, so after we do that, we build it. So we launch Packer, loads the project files, we do Ansible, kind of, and then Packer builds the AMI. Here, kind of again, just code stuff here, and look at the slides once you get out of here to get more detail. Variables we pass in, details for creating the AMIs, right? Then load the application in there. Actually do the testing as part of our build process. So we're actually doing dynamic testing against our code before it's deployed. We can actually do testing. There are a number of tools here. Again, could be unit tests, could be code assessments and vulnerability assessment. Here's a little tool that we like called Gauntlet. Allows you to do actual network testing of your stack as it's being built, and then we deploy it, right? So pull the AMI from the console log, run a rolling update script to actually age out your instances that are already there, and then replace them with the new ones. So that's kind of how we do patching. We don't go with our little floppy disks. You remember floppy disks? So we don't go around with our floppy disks anymore to update all these servers. We actually just basically kill the server, spin it back up in an environment that we know. Now let's go to the SecOps piece of things, right? There was DevSec. Now we'll do SecOps piece, so automating security operations. So here are a couple of different design principles and operations principles to think about. First, software-defined security. We want to be able to program everything. So security folks, and one of the things I ask security crowds now is, how many of you started as developers? Handful raised their hands. I go, for those of you that didn't start developing, find something else to do, because that's where the future is going. And everyone goes, oh, and kind of all sorts of sphincter tightening and that, and I go, no, I'm just kidding. You don't have to go find another job, but what you do have to do is you have to understand scripting. Right? Because that's how a lot of this is going to happen over time. That's how all of our code is. When we want to be integrated within this whole DevOps thing to make it DevSecOps, we got to talk the language of code. So software-defined security, stateless. I don't want to have to maintain processes. I don't want to have to maintain state as I'm trying to figure out how to implement security controls. Why? Because then I am actually running traffic unnaturally as opposed to within the stack as it is meant to be. So we want to be stateless in that case. We want to be event-driven. We'll talk about that in a sec. And we have to have continuous feedback loops. Why? Because we learn, right? And new attacks happen every day. Any of you that are on any of the vulnerability lists or what have you feel that pain, right? New attacks happening every day. New services are available almost every day. We've got to keep track of all these things. So the idea that we've got continuous loops, making sure that we are on top of everything, is absolutely critical. So what are the categories of these operational motions? First is guardrails. We'll mention that. We'll dig into that quite a bit. Then we have workflows, and then orchestrations, where we're basically making a lot of different discrete tools work together due to the magic of APIs and code. So what is a guardrail? It's basically this idea that I do an assessment, so I'm finding where I have an issue, and then I'm deciding whether I want to fix it or not. Right? So find. What's the second one? And then fix, and then there's something on the other side. I can't even see that because this thing, eval, right? And then fix it. So we want to make sure that our guardrails account for different environments, because we're going to want to lock down our prod environment a lot tighter than our dev environment. So our guardrails for prod should be, nobody gets to touch this like ever. Right? Everything has to go through the pipeline. Everything has to be within our DevOps process and make sure that it works that way. Whereas dev, we can be a little bit less draconian about it. We want to make sure that we are handling exceptions and evaluating the issues and then fixing and remediating things automatically. Here are a couple of different example guardrails. I'll point out one or two of them. Disable access keys that haven't been used in 90 days, because why would anybody, what could go wrong if you have an access key just lying around? Right, so get rid of those, either kind of deactivate them or disable or delete them. Create baseline IAM users, validate monitoring and alerting are properly configured, and fix it if it's not. So again, there are about 70 or 80 of these guardrails that we've defined. There are a whole bunch more that we're planning as well. In terms of building one, you've got that process there, and here is an example to find an open admin port, right? Because what we want is to make sure, because we're running immutable, we don't want our administrators, we don't want anybody to log into these servers, so we want to turn off the open admin ports. We can actually look for that within our environment, and that's pretty easy. Right? Self-healing infrastructure. So this is something that you spin up together in order to find a security group. The event is recorded to CloudTrail, pass to CloudWatch. triggers my alert, and then my Lambda function actually analyzes it and reverses it. We've got code for that in the repository as well. And here's the list or the links to our GitHub repository. We've got a couple of different code snippets for what you can do from an automation and alerting standpoint there. Here's some stuff for workflows. This workflow example is a incident response motion. So what it does is you just feed it an instance ID, and then it takes a whole bunch of different actions, moves it into a quarantine group, spins up an analysis server, and that happens within a couple of seconds, which evidently I don't have, since these guys are out here with the. So I have family that ran the Apollo Theater in New York, and they had the guy that came out and pulled you off. Am I getting the hook yet? No. Oh, beeped at me. Crap. All right. So workflows, device, orchestrations. So the orchestration, I won't point that out, is that what we're trying to do in that example is make sure that all of our internet-facing devices are behind a cloud WAF. So you can actually check in your cloud console which instances have port 80 or port 443 open. We know they're web servers at that point. If they're not provisioned in the cloud WAF, provision them, do it all through the APIs. Things are great. There's some complexities there. Where to start? Yep. Okay, so summary, right? Cloud security begins with architecture, ends with automation. So, right, we need to think specifically about architecture and how we can reduce our attack surface specifically, and then automate things where possible from a secure ops motion. There is no quick and dirty. DevSecOps, look to integrate the security mindset into your DevOps culture. Security is everyone's responsibility. That is one of the most horribly overused platitudes in security, but it actually happens to be true. So the more we can get folks understanding on the dev side and on the ops side how security can and should be integrated into their environment, the better. Codes and snippets and slides are there. And again, as I mentioned, we've got a bunch of information on open source tools and container security. And if you're interested, sign up for our newsletter. We post all sorts of interesting bloggy type stuff to educate you on what's going on with a security standpoint. So I believe I am out of time for questions. Maybe one? No? All right.
Mike, that was awesome.